But one of the most powerful uses of the standard deviation is when we apply it to the normal curve. Now, the normal curve is a special type of density curve. Now, what's a density curve? Well, a density curve is a curve that sort of shows the trend of a distribution, for instance, and it's sort of smoothed out. So, for instance, if we're looking at, let's see, let's make this a little thicker. There we go. If we're looking at this histogram here that we have, if we wanted to look at the density curve would kind of go like this. It shows the trend. Now, there's important features here about that density curve. First, it will always be on the horizontal. The area underneath that density curve will always be 1. So obviously, as the histogram bars get closer and closer together, it becomes closer and closer to 1, and it will always describe the overall pattern. So when we're talking about the density curve and we're talking about the actual observations of our data, we use different terms. We know that when we're talking observations, we refer to the mean as x bar. Well, in a density curve, we refer to it as mu, the Greek letter mu. For observations, we know that the standard deviation is s. And for the density curve, a standard deviation will be referred to as sigma. That's a lowercase sigma, just so you know. It kind of looks like an O in cursive. Now, a normal curve, as I said, is a special kind of density curve. It is symmetric, it is unimodal, and it is bell-shaped. Now, the center of the normal curve is the median. And at the same time, since it is symmetric, it is also the mean. Now, these little tick marks kind of show us the number of standard deviations. So if we are one standard deviation above the mean, we're here. If we're 2, and if we're 3, go here. Going the opposite direction, -1 standard deviations, -2 standard deviations, and -3 standard deviations below the mean on the left-hand side. We've got the same thing here, but now one of the reasons we bother with the normal curve is because we know some things about it. For instance, if we are between, let's say, let's use red for this one. If we are between 1 standard deviation above and 1 standard deviation below the mean, we know something about that. We can apply what's called the empirical rule. It is sometimes referred to as the 68, 95, 99.7% rule. And the reasoning for this is really very simple. Hang on here. Yep, there we go. And that's because it tells us every time, no matter what our normal curve looks like, when we are between 1 standard deviation below the mean and 1 standard deviation above the mean, we have 68% of the values captured in there. So 68% of the data is between plus or minus 1 standard deviation from the mean. And then, if we go out a little bit further, if we go out 2 standard deviations above and below the mean, we find that we have 95% of the data. So I'm going to color that in here. There we go. 95% of the data is between 1 and 2 standard deviations above and below the mean. So that's what I have shaded here in green. So 95% of the data is between the mean plus or minus 2 standard deviations. And then finally, we get to the outside here, and we have 3 standard deviations above and below the mean. And you'll notice that when we're here, we are almost, there's just a minuscule amount that remains. And we can see that right here, that this then is their 99.7%. Almost all of the rest of this curve is going to be filled in, and so we know that 99.7% of our data is the standard, as the mean plus or minus 3 standard deviations. That's useful to us because it allows us to see, if we have a score that if we're at the mean, we know that our score is higher than 50% of everyone else's. If we're at 1 standard deviation above, then we know we can do some calculations and we can figure that out. And that's what we're going to be working on in class tomorrow.